Hello student, welcome to my official YouTube channel Mathematics All Level, and today we are discussing the concept of periodic sequence, recurrence relation and sigma notation. This is the fourth video of this series, and earlier we have uploaded the 3 videos on the same concept of sequences and series, which can be discovered on my playlist. So I'm taking the challenging questions from 2018 onwards, which belong to the same concept which I have written here. So let's start. The first question which I have taken is of the periodicity. They have given sequences of terms here, a1, comma a2, comma a3, which which is defined by a particular relation, that is a1 equals to 3. Now what we need to do, we'll be plugging n equals to 1 in this equation. So what we'll be getting, a2 equals to 8 negative of a1. So 8, a1 is here 3, so we'll be getting 5. So a2 we are getting as 5. Now what we need to do, again we will be plugging 2 in this equation. So we'll be getting a3 equals to 8 negative of a2. So it will be equals to 8 negative of 5 will be equals to 3. Similarly, we'll be plugging n equals to 3 here. So we'll be getting a4 equals to 8 negative of a3. So a3 here is 3. So we'll be getting 8 negative of 3, that is equals to 5. So we can see here that the series which we are getting here is 3, 5, 3, 5. This is how the series will go on continuing. Now, what the first part was, so that the sequence is periodic, we can see here that the sequence is periodic. And what is the order of this periodic sequence? So you can analyze it here that after every 2 terms, the terms are getting repeated. Okay, so after every 2 terms, the terms are getting repeated. So the order of this periodic sequence will be, student, 2. Okay, so we have got the value of this order of this periodic sequence. Now this major question is, find the value of sigma notation n equals to 1 to 85 an. Now if I look at the sigma notation n equals to 1 to 85, this is an. Now think for 85, see this 85 term, how we need to calculate. First, what we need to do, we'll be taking out the total number of terms to sum, which is equals to 85. So we'll be writing it as here, total number of term to sum is n equals to 85. Okay, so if I want that how means number of full period for this sum 85, so what will be the means how we should proceed ahead. So number of full periods will be equals to, we know that number of full period will be equals to sum upon the periodicity of this particular sequence, that is 2. So which we are getting 85 by 2, that is equals to, if I take this part, so we will be getting 42, and the remainder here will be 1. Means the absolute value is 42 and the remainder here is 1. So for remaining term, what we need to do, I'll tell you how to proceed ahead. Okay, 42 is the full periods. Now look at this part, 3, 5, 3, 4, 5. Look at this part. We'll be seeing it 3, 5, 3, 5. This is how the sequence is moving ahead. We have got the number of full periods as 42. So for this, what is the sum of the first 2 term, which is getting repeated after every 2 terms? That is equals to 2. Sorry, that is equals to 8. So what will be the sum here, student? I'll tell you. 42 cross of 8 plus of the first term, that is 3. How I directly wrote it, I'll tell you. Sigma n equals to 1 to 85 an. Okay, how I directly wrote, I'll tell you. This is the sum of the first 2 element, which is getting repeated after every 2 terms. So the sum will be 8. Okay, now we have calculated the number of full period as 42, means 42 times this sum will occur. So that is why I have calculated. I have written 42 cross of 8. Now why I have written plus 3 here? Because the remainder was 1. It means that one more term will be coming after the after 42 terms are written. So one more term will be coming after this 42 terms which I have written is I have mentioned here. So what will be the one more term, what will be the next term after writing 42 terms, or to 2 times these terms? That will be 3. So that is why I have written 3 here. Okay, so we'll be getting the value as 336 plus of 3, that is equals to 339. Okay. So this is the concept behind this, means to calculate the value of this sigma notation n equals to 1 to 85. Now let's move to the next question, student. Yeah, they have given us particular sequence here in which they have given the relation also, and they have mentioned the value here, that is u1 equals to 2. So what we need to do, we will be plugging this u1 directly here. So n equals to 1. So for n equals to 1, what will be getting? u2 equals to k negative of 24 on u1. On further solving, we'll be getting k negative of 24 by u1. u1 here is 2, so equals to k negative of 12. Yeah. So u2 we are getting as 12. Now what we need to do, we'll be plugging n equals to 2. So what we'll be getting? u3 equals to k negative of 24 upon u2. That will be equals to k negative of 24 upon u2 here is k negative 12. Yeah. In the question, they have given that u1 plus of 2 u2 plus of u3 equals to 0. So we are not going ahead with plugging the value of n equals to 3, because we were having the requirement of 3 u3 and u2. So u2 and u3 we have calculated. So I'll be doing it again. So I'll be using this relation, student, u1 plus of 2 u2 plus of u3 equals to 0. Okay, so here what we'll be getting, u1 was 2 plus of 2 u2, 2 times of u2. u2 will be k negative of 12 plus of u3. u3 here is k negative of 24 on u2 was k negative of 12 equals to 0. Now I am using this relationship, student. Okay, so what we need to do, okay, we'll be solving it further. So we'll be getting 2 plus of 2k negative of 24 less of k negative of 24 upon k negative of 12 equals to 0. Here we'll be getting 2k negative of 22 plus of k negative of 24 upon k negative of 12 equals to 0. Now we'll be taking the LCM on the left hand side. So and LCM on the left hand side, so we'll be getting 2k negative of 22 cross of k minus of 12 plus of k negative k cross of k minus of 12 negative of 24 whole divided, denominator will be k negative of 12. So we'll be getting this as equals to 0. Now this k negative of 12 will get multiplied on the right hand side, so we'll not be considering it. So here we are getting, what we need to do, will be opening this out. So we'll be getting a particular value. So we'll be writing it 2k square negative of 24k negative of 22k plus of 264 plus of k square negative of 12k negative of 24 equals to 0. This k negative of 12 we have multiplied directly on the right hand side, so we'll not moving ahead with this k negative of 12 denominator which we are talking about. Now 2k square negative of 12 24 will be collecting the terms having the same values here, same coefficients here. So yeah, so what we are getting as the final equation here, student, that is 3k square negative of 58k, which they have given in the question, 240 equals to 0. Okay, so this was the relation which they were asking for, 3k square negative of 58k plus of 240. Now in the question they have told find the value of k, giving a reason for your answer. So we can find the value of k from here by the help of factorization or by the help of the quadratic formula. So quadratic formula, we know that for getting the value of k, if we are applying this for quadratic formula, so we'll be getting negative of b plus minus of b square minus of 4ac by 2a. This is the quadratic equation formula. Don't get confused if you have not studied quadratic equation formula. So this is what I am applying here. So we'll be getting here the value of k equals to negative of b is 58. So we'll be getting 58 plus minus of under root of 3364 negative of 2880 upon 6. This how I got, means b square, that is 58 whole square, negative of 4 ac, a is 3 and c is 240. So this what we are getting as 58 plus minus of root of 484 on 6. This we know root of 484 is the value of 22. So k here we are getting as 58 plus minus of 22 upon 6. So if we are taking positive value, so we are getting the k equals to 58 plus of 22, that is equals to 80, and upon 6, that is 80 by 6. So the value here is 40 by 3. Okay, and if we are taking k as negative, the term means the operation here as negative, not k, the operation here as negative. So we'll be getting the value of k equals to 58 negative of 22, that will be equals to 36 upon 6, that will be equal to 6. Now come in the question, student. In the question they have mentioned here where k is an integer. Okay, so k is an integer, so the k is an integer, so this will be only possible value of k, not this. Okay, because it is a rational number, and this they have told that k is an integer, so this will not be possible, this value will be possible. Okay students, so don't forget to mention, because they have mentioned that k is equals to k is an integer here. Now if k is equals to 6, now they have asked us to find the value of u3. So we'll be plugging this value of k equals to 6 in u3 here. So we'll be getting k equals to 6. So directly we'll be writing it u3 equals to 6 negative of 24 upon 6 negative of 12 will be negative of 6. So here we'll be writing negative of 6. So what we are getting here, student, okay, so we are getting this value as, yeah, negative of 24 upon k negative of 12. So this we are getting, yeah, so we'll be getting this u3 as 6 plus of 4, because this and this got cancelled, so negative sign will be positive. So we are getting this u3 value as 10. So this was our solution, student, that u3 we have got as 10. Okay, now let's move to the next question. This is one of the good question they have given in this this reoccurring relation. Now let's do it. They have given a certain series. Now if I say if n is odd, if n is odd, I'm just taking the I'm just taking this term now, this term for your convenience. I'll be breaking it into the part. So if n is odd, so cos 180 cross of n, what will be the value? Will be getting negative of 1 raised to the power n. Okay, if it is under certain relationship of n equals to 2 to infinity, means if we are plugging the value of n equals to odd term, so we know that we will be getting negative of 1 raised to the power n, means we'll be getting the negative values here. But what if I say that if n is even, so how, what value will be getting for cos 180 cross of n, that is positive, that is positive. So for this part we have two conditions, that n is odd and n is even. So for n is even, no issue is there, but for n is odd, the value which we'll be getting, that is will be equals to negative of 1 raised to the power n. So can we write n equals to sigma n equals to 2 to infinity 3 by 4 raised to the power n, this part as negative 1 raised to the power n. Even if you want to write positive 1 raised to the power n for n equals to even, you can write it, but the value of positive 1 raised to the power n will always be 1, so we are not mentioning it here, and we will be mentioning only for negative of 1 for n equals to odd. So if we are combining these two terms, so what we'll be getting, sigma of n equals to 2 to infinity negative of 3 by 4 raised to the power n. Okay, means negative of 1 I have combined with this term, so we'll be getting negative of 3 by 4 raised to the power n. Okay, now let's write few terms for this. Negative of 3 by 4 means few terms with expansion, I'm writing it here. So we'll be getting negative of 3 by 4. The first term here will be n equals to 2, so it will be 2 plus of again negative of 3 by 4. Next term will be 3 plus of negative of 3 by 4 power 4, and this is how the series will go on. This is just for explanation, students, till infinity. This is for just for explanation I'm writing. Why I've written this? You can see here that this is forming a geometric progression and it is going till infinity, means what we need to do, will be finding the sum of the infinite terms, that is equals to a by 1 negative of r, where whole square. So this will be again multiplied with 3 negative of 3 by 4. So we'll be getting positive of 9 by 4 and 9 by 4, this will be the remaining and term, and here we'll be getting 7, and this multiplied term will be equals to 1 by 7, that will be equals to 9 by 28. Yeah, this was the mistake which I have done here. The first term, this is a is the first term, so the first term here is negative of 3 by 4 whole square, so it will be equals to this part 9 by 28. Yeah, this 4 and this 7 got multiplied, they both were in the denominator. So this is how the solution will come, students, and this was just for your explanation part, that how we are expanding this series. Okay, now let's move ahead with the next question. Yeah, we need to show a particular relation, that sigma of r equals to 1 to 16 3 plus of 5r plus of 2 raised to the power r equals to 131,798, which is most common question in this from sequences and series. Just what we need to do, we'll be segregating all the terms here. So here we'll be getting like this, we could write it 5r plus of sigma r equals to 1 to 16 to r. Okay, we are taking left hand side, student. So okay, so now what we did, we have segregated all the terms of this means all the terms on the left hand side. Okay, now if I say, just let's go it one by one. If I say what is this, so I'll be writing it here. Sigma of r equals to 1 to 16, 3. What does it means? Means this 3 will be repeating 16 times. So we can write it as 3 cross of 16, that is equals to 48. Okay. For your explanation, I'll be explaining it here, that 3 plus of 3 plus of 3 dot dot dot, it will go till 16 times. So that is why I have written. Okay. This summation means this how we need to expand. This is just for explanation, student. Okay. Now let's go ahead with this part. So this part is sigma r equals to 1 to 16, 5r. Okay. How it will be expanded? It will be expanded in the format of, I'll be writing it here, 5 plus of 10 plus of 15 dot 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 till 16 times. This is how it will move on. Okay. How I got the values here, 5, 10 and 15, we are plugging r equals to 1, r equals to 2, r equals to 3. So we are getting like this. So for this part, if I say 5 cross of r we are plugging 1, 2, 3, 4, 5, like this we are moving ahead. So we know we have already derived this formula, the sum of n terms of an AP is given by n by 2 cross of a plus of L. So this will be here 16 by 2, okay, because 16 times it is getting repeated. 5 plus of the last term, which we can calculate it here, that will be equals to a16 will be equals to a plus of 15d. So a here is 5 and d here is 5. So we are getting it as 80. Yeah, 80. So this could be written here as 80. Okay. So we have written this part. So it will be equals to 16 by 2. 16 by 2 cross of 85. You'll be getting 2 8 so 16, and the value here which we are getting it as, the value which we are getting here is 680. So okay, now let's take this part, student, this part. So this part is sigma of r equals to 1 to 16, 2 raised to the power r. Now again for the explanation part, I'll be writing it here. So we are plugging r equals to 1, so we'll be getting 2. We are plugging r equals to 2, so we'll be getting 2 square plus of 2 cube. This is how the series will go on, and it will be repeating 16 times. So we could write here that it is we'll be applying the concept of sum of geometric progression, because it is a geometric progression and the first term is 2, and this common ratio here is 2, and that's n also is mentioned, that is 16. So we have derived that formula, a r raised to the power n negative upon r negative of 1. So a here is 2, r here is 2 raised to the power 16 negative of 1 upon 2 negative of 1. Okay, so yeah, so it will be equals to 2 times of 16 will be equals to 65536 negative of 1. On calculating it, we are getting 131070. Okay, now we have got the values here, students. This is our one value, this is our one value, and This is our one value. What we need to do, we need to just add all the values. So what we'll be getting, 48 plus of 680 plus of 131070. So on calculating it, what we are getting, final value we are getting 131798. So this is uh, the answer which they were requiring. Okay, so okay, this was the end of this question series, students. So hope you like my video. Stay tuned, we'll be coming with more videos. Thank you.